In this lesson, we are going to learn a little bit about math properties. A property is a math statement that is true for all numbers. We already have talked a little bit about order of operations and the fact that order of operations is important because it tells us what order to do all math problems in. And that's important so that everybody solves problems the same way and gets consistent answers. Properties are important for similar reasons as order of operations. Properties tell us how we can work with numbers in math. So in other words, they tell us what things we are or are not allowed to do with numbers. That's important. We all need to treat numbers the same way because if we're not treating them the same way, we're going to get different answers. This lesson, we're going to talk about some of the basic properties that are good for you to know about. Some of these properties, informally, you probably already know. So some of the things we're going to say might seem logical or things to you where you think, okay, yes, I knew that. But what we're going to do is add some vocabulary in with those properties. There are some different types of properties. One type of property is what's called an identity property. Identity properties are properties that tell us about how to keep the value of a number the same. So in other words, how to take a number and not change it into something different. There are two different identity properties that you should be aware of. One deals with addition, and it's called the additive identity. A second one deals with multiplication, and it is called the multiplicative identity. Again, identity properties tell us how we can do things to a number that will keep the value of the number the same. When we're adding any number, we'll call our number x because we can make it any number we want. If we're adding and we want that number to not change, the only way to do that with addition is to add 0. Adding 0 keeps the answer the same. So that's what the additive identity says. The additive identity says that when you're adding 0 will keep your answer the same. The multiplicative identity is a similar idea, but with multiplying. So it tells us what can we multiply by if we want our answer to stay the same. So whatever number we're starting with, the only way to keep the number from changing when we're multiplying is to multiply it by 1. Multiplying by 1 does not change the answer. That's what the multiplicative identity says. It says that any number times 1 will stay the same. These properties are actually going to be important because, along with some other properties we're going to talk about, we are going to use identity properties in our next chapter to help explain why some rules that you're going to learn work. So properties can be used to help explain some of the rules for math that we use in other places. There are a couple of other properties that you should know about. You are probably aware, because you've been using it informally for a while, that if you add two numbers or you multiply two numbers, it doesn't matter what order you do that in. So if you do 2 plus 3, that will give you the same answer as doing 3 plus 2. The same thing works for multiplication. If I do 4 times 5, that gives me the same answer as doing 5 times 4. So when you're adding or multiplying, it doesn't matter what order you add or multiply the numbers in, the answer will still be the same thing. There is a property that says that. The property that says that it does not matter what order you add or to multiply two numbers in is called the commutative property. Again, this property is something that you've probably used informally before, but now we're going back and we're giving it a name. So whenever you switch two numbers around that you're adding or multiplying with the knowledge that the answer is not going to change, you're using the commutative property. So again, the commutative property says that two numbers can be added or multiplied in any order without changing the answer. It does only work for addition and multiplication. If you think, if I tried the commutative property with division, if I did 6 divided by 3, that would give me 2. If I try to switch that around, 3 divided by 6, that gives me 1/2. The answer changed. 2 and 1/2 are not the same thing, so it does not work for division. Something similar also happens with subtraction. If you change the order of subtraction, you get a negative answer when you would have had a positive answer before. So it doesn't keep the answer the same. So it only works for adding and multiplying. One thing about commutative property that's really important, which is also the difference between the commutative property and the next property that we're going to talk about, is how many numbers you're working with. So commutative property is when we're working with two numbers at a time. There is another property that we can use that says something similar to the commutative property, but it is used when we're working with three numbers. That property is called the associative property. Oh my. There we go. The associative property says something basically the same as the commutative property, but it is used again when we're working with three or more, but usually three numbers at a time. So the associative property says that when we're adding or multiplying, just like with commutative property, we can change the order or change the way that we group the numbers when we're adding or multiplying. If we change the way the numbers are grouped, basically what we're doing is we're changing the order of addition or multiplication, which is what commutative property does with two numbers. So associative property, again, says when we're adding or multiplying, just like commutative property. But this time, we're working with three numbers. And again, that's the difference between commutative and associative. Two numbers versus three numbers. When adding or multiplying three numbers, the grouping of the numbers or the order that we add or multiply the numbers can be changed without changing the answer. This one I want to give you an example of because it actually connects to some things that we've learned about order of operations. Let's say that we have 3 different numbers. I'm going to put a variable in there just because I can, because it will also let me show you something else at the same time. So let's say I have some different numbers that I'm adding. Maybe this is part of an equation that I'm working with, since we were just talking about equations in the last lesson. So maybe I have part of an equation, and part of the equation is something like this. 2 plus x plus 5 in parentheses. Now, order of operations tells me that I would have to do the x plus 5 first because I have to start in parentheses. And then I would do the 2 second. So my order of addition would actually be x plus 5 plus 2. The associative property says that I can add in any order that I want to add in. So if I wanted to change the order, I could move the parentheses somewhere else to change the order of the problem. So maybe I could change the order of the problem and I could make it be 2 plus x plus 5. So I just changed the order by moving the parentheses from x plus 5 plus 2 to 2 plus x plus 5. It's a different order, but it's still going to give me the same answer. One thing that you can do if you combine properties is you can also use properties. So if we put commutative property and associative property together with this problem, we can use properties to rearrange a problem to help us work around variables or work around information we might be missing. So for example, if I wanted to work around some things on this problem, I could use commutative property with these 2 numbers and switch the order of the numbers. So now the problem would look like this: 2 plus 5 plus x. Then I could use associative property to change the order that I'm adding the 3 numbers. Instead of doing 5 plus x plus 2, I could do 2 plus 5 plus x. So I flipped the order of a couple of numbers, and then I flipped the order that I was adding all 3 numbers. By rearranging the numbers, what I did was I got the 2 numbers that I know in the same place. Since those are in parentheses, I would do that first, and I know what both of those numbers are. I can do 2 plus 5. 2 plus 5 is 7. So I could take this problem and I could rewrite it in a shorter way and change it into 7 plus x. So I worked around the variable and was able to combine some pieces around the variable to make the problem shorter and simpler. Now there is one last property that we need to talk about, and it is the property that connects to the intro to this problem that you did. And it is called the distributive property. The distributive property you are going to use a lot as you learn more about algebra. So this is a good introduction to the property. The distributive property is useful if I want to be able to rewrite something without parentheses. So an example of the distributive property might be something like this. Maybe I wanted to do this problem. And I'm actually going to work through the problem both ways so that you can see that it gives the same answer either way. If I wanted to solve this problem following order of operations, then I would need to start in the parentheses and do the 3 plus 2, which would give me 5. So that would turn this problem into 5 times 5, which is 25. So we know the answer to this problem is supposed to be 25. So now, keep that in mind. We are going to rearrange this problem. Distributive property says that if I am adding or subtracting in parentheses and then multiplying the answer, rather than adding or subtracting first and multiplying second, I can multiply each individual piece. So that's where the name distributive property comes from, because we're distributing or we're sharing the multiplication across everything in the parentheses. So that means I could rewrite this problem. Instead of doing 3 plus 2 and then multiplying by 5, which is what we would normally do, I could do 5 times 3 plus 5 times 2. So I'm taking each of the pieces in the parentheses and I am multiplying them by what they would have normally gotten multiplied by after I added. Now, if we test this out, we could see that this still works. If we follow order of operations from here, 5 times 3 is 15. 5 times 2 is 10. 15 plus 10, still 25. So that's what the distributive property says. So the distributive property says that if I want to multiply by a sum of a number where I'm adding, a different way I can do that is to multiply each number that I'm adding and then add the numbers. Distributive property can be really convenient when you're trying to do mental math. So, for example, if I gave you a problem like this, seven times 98. Now, if I asked you what is 7 times 98, that would have a lot of you reaching for your calculators. I could use distributive property to help me do this in my head. If I want to use distributive property to help me do this in my head, actually, I could change this number to an addition or a subtraction problem that's easy to work with. 98 is really close to 100. It's only 2 less than 100. So rather than trying to do 7 times 98 in my head, it's going to be easier to think about 7 times 100 in my head, and then I just have to subtract 2. 98 is 100 minus 2. Well, that just gave me some numbers that are a lot easier to work with, because distributive property tells us when we're adding or subtracting, rather than doing the adding or subtracting and then multiplying, I can multiply each of the individual pieces that I'm adding or subtracting first. So I could say, okay, I'm going to multiply the 100 by 7. Well, that's easy to do in your head, multiplying by 100. 7 times 100 is just 700. And then I would also multiply the 2 by 7. Again, 7 times 2 is a much easier problem. It's 14. So to get the answer in my head, I could just do 700 minus 14. So that is a much easier problem to figure out, and it's something that a lot more people would be likely to be able to work through in their head. So 700 minus 14 is 686. No calculator needed. So distributive property can help you to work things out in your head. It also is going to help you with some other things that you're going to learn about algebra as you go down the road through middle school math.